Hi guys, what's up again? In the previous videos, we gave an introduction to reaction kinetics and how to calculate the average rate of a reaction. So far, we have discussed the rate of reaction for the decomposition of nitrogen dioxide only in terms of the reactants. So the rate of a reaction can also be expressed in terms of the products. However, in doing so, we must take into account the coefficient of the reactants and the products in the balance equation for the reaction, because the stoichiometry determines the relative rate of consumption of either the reactant and the generation of products. So for example, in the balanced equation above, we have nitrogen dioxide decomposed into nitric oxide and then oxygen gas. So recall that from the previous video, the graph for the decomposition of nitrogen dioxide was given as this. So we have here concentration, the unit of concentration, which can be molar, which is also the same thing as mole per dm cube, and it can also be mole per liter. So here is the time in seconds or any unit of time. So recall that the concentration of the reactant nitrogen dioxide decreases with time. So we have nitrogen dioxide. So the concentration of the products increases with time. So we have nitrogen oxide. So note that the curve for nitrogen oxide is the same shape as the curve for nitrogen dioxide, except that it is inverted, that is, it's upside down. So in the balance equation, the product oxygen has a coefficient of 1, which means it is half as fast as nitrogen oxide, since nitrogen oxide has a coefficient of 2. So looking at the rate here, we have that negative 1 over 2. Recall that the coefficient of nitrogen dioxide here is 2. So we have negative 1 over 2, change in concentration of nitrogen dioxide over change in time equals to positive 1 over 2. Recall that the coefficient here is 2. So we have change in concentration of nitrogen dioxide over change in time. And we also have, because the concentration here is 1, we have positive 1 over 1, which is the same thing as 1, change in concentration of oxygen over the T. So we can simply say that the rate of consumption of nitrogen dioxide is the same as the rate of production of nitric oxide, but they are twice the rate of production of oxygen gas. So we can say that change in concentration of nitrogen dioxide rather, is this, and we have this is equals to change in concentration of oxygen over time. So here is a simple quiz. The reaction B plus 2C gives to D and has a rate of 2.53 times 10 to the power minus 5. So what is the rate of reaction in terms of formation of D, C, and B? So the first thing to write is to write out the rate expression. So we have that rate equals negative 1 over 1, since this is the reactant and its concentration decreases with time. So we have negative 1 over 1, change in the B over the T. And we also have negative 1 over 2, change in the C over the T. And we have a positive 1 over 2, change in G over the T. So we have that 2.53 times 10 to the power minus 5 as the rate. So what is the rate of the reaction in terms of formation of D? So for D, we have that 2.53 times 10 to the power minus 5 equals to negative 1 over 1 dB over the T. So the rate for D. Sorry, this is D, not B. D. So the rate is 2.53 times 10 raised to the power minus 5 times minus 1. So for C, we have that 2.53 times 10 raised to the power minus 5 equals to negative 1 over 2 the C over the T. And therefore we have that 2 times 2.53 times 10 raised to the power minus 5. And that's equals to, we have it to be 5.06 times 10 raised to the power minus 6 molar per second. For the last one, so we have for rate for B, and that's simply 2.53 times 10 raised to the power minus 5 equals to 1 over 2 d over the t. Therefore, we have that is equals to 5.06 is 5 times 10 raised to the power minus 6 molar per seconds.